Hi, ladies and gentlemen. We're going to look at this access to water, and this is 4.2. So I'm going to go through from the beginning, but if you were just in class, you can just jump to where we left off, and then I will upload the actual presentation as well. So if we look 4.2, these are some of the things from the IB Guide that we're supposed to be accomplishing, so you can take a look at them, you can pause it, and just read through them or bring it up in the slideshow. So we're trying to look at differences in access to fresh water, what impacts access to fresh water, and then how we could possibly learn about these conflicts and come up with some solutions if there are any. Think about it. So here's some really shocking facts. So I just want you to read through them quickly and think about the information provided, but as well as what is your experience. So it says 1.1 billion people live without clean drinking water. That's a huge portion of people. And if you've lived consistently, like in Italy or in the United States or in the UK, you don't have this type of issue, but it is an issue worldwide. Then it says 2.6 people live without basic sanitation or adequate sanitation. So that means you're living in an area that is clean. Okay, so that might include things like having a flushing toilet or a place to use the restroom that is not going to contaminate, your situation and your home or your area. 1.8 million people die every year from diarrhea. So we talked about the diarrhea. Diarrhea can be caused by toxins or toxins or pathogens within water, and the toxins or the pathogens within the water can make you really sick. Like you can get what's called dysentery, so you have diarrhea for an extended period of time, and if you don't get it cured, you don't die from just the diarrhea, you actually die from dehydration. So as you get diarrhea, you get more dehydrated. And in class, someone shared that because you're dehydrated, you might actually end up drinking more of the water that's available, which could potentially still be contaminated with some sort of pathogen that's causing the diarrhea itself. So that's really bad. So it's not going to get better, okay, without seeking help and medication. 3,900 children die every day from waterborne diseases. That's a lot, okay? So every day, not every year, every day. And 260 river basins are shared by 2 or more countries. So I want you to think about the issues that came up within those case studies and how these issues then apply to these places where water ownership is really a big question. Like who owns the water, who can decide what happens to it, etc. So think about it. It says wheat. I'm going to actually I'll add the gallons and liters because a gallon and liter are a little bit different and it changes units down there. So I'll look that up. But the wheat and rice take over 1,000 liters to produce just 1 kilogram. Okay, that's from the beginning, so from germination to actual harvesting of the product. Beef, on the other hand, if you have cows and you want to raise them for beef, it says 13,000 liters of water. So this is these are really big numbers, but beef is significantly more than the wheat and rice, about 10 times more. And even to produce a water bottle, this sounds kind of crazy, but to produce a water bottle requires more than the water, more than the quantity of water that is put into the water bottle, because you have to produce the plastic, the labeling, shipping, all of that. So we're thinking about how it is that we're consuming and using the water. Scarcity. So in reality, the most of our water goes toward agriculture and industrial purposes, not domestic purposes, even though we often talk about how we can reduce domestic water use, which is important, and it's something that we can actually change, but that's not where the majority of our water is going. So the other issue that we see is the distribution of water is uneven. Of course, we saw that in the case studies, right? So some people are taking a lot of water. Some people have a lot of available water that they can decide what to do with. And it's never going to be evenly distributed. So then we look at this. So by zone, if we're looking at geographic zones, we've got blue is the percent of available water. And then yellow is the population, and we see an uneven distribution. So essentially, some people have a bigger population than the available water, but these two are fairly close, so Africa and Europe. Though, to be totally honest, water is not evenly distributed within those continents, of course. So there are zones of more water availability in times of the year with more water availability than others. So it's not that it's perfectly distributed, it's just that overall within the continent, it's fairly balanced. And then here we have zones where there's way more water available than there are people living there. Freshwater stress. So this is 1995 to a 2025 projection. So we're looking at the blue. So the blue is telling us that there's a fairly low water stress, okay? And then the orange or yellow, whatever you want to call it, so the more orange it gets, it's the more stressed it is. So we can see already, if you look really carefully and zoom in, that in 1995, Italy is kind of the light orange color, and the US, I'm just going to refer to the US, is in this lighter blue zone. And then as we move to 2025, we see the US becomes that light orange, Italy actually remains the light orange, and then we see some other countries getting to the dark orange and to the light orange, including this. So this is China, so that's a big concern, as there's a huge population within that zone. In class, some people brought up South Africa. We know that South Africa currently is having some major drought issues, and there's a huge fear that they're just running out of water. They're needed to import water, etc. So it was already the light orange in 1995 and is the really dark orange in, well, probably now, but 2025. Water usage, so looking at that distribution again, remember we said that overall our domestic usage is fairly low, and if we break this apart into the less economically developed countries and the more economically developed countries, we see some differences. And as these countries actually get on board, so this is not telling us total quantities, it's only telling us percentage that's used in each way. As these countries become more industrialized, we might see a lot more water being used in industry and perhaps less being used in agriculture. Sustainable water use, you should be very familiar with the term for sustainability, so this is really good for you for review for your final. So sustainable water use, we're looking at using water in a way that's not negatively impacting future generations, so that we're keeping that nice balance. So we're keeping it at reasonable levels where future generations can continue to use the water and it's never going to be depleted. So we're especially worried about fresh water sources. Aquifers are zones underground where water is stored. So that's actually where a lot of people get their drinking water and their usable water in their homes. So they drill down and essentially make like a well and pump that water out. Water scarcity and water degradation. So what are the issues? Okay, population. The human population is growing and growing, and we don't see any signs of that stopping. Okay, though by country, some countries have balanced out, or their population is no longer growing, and within those countries the population is sometimes even declining, but the overall world population is increasing, meaning there's going to be more demand for water worldwide. Climate change impacts water availability, so with increased climate change we expect increased droughts in some zones as well as floods in other zones. Agricultural practices, so depending on what we're growing, and we have to decide if the stuff we're growing in the zone is the best type of organism to grow there, because maybe we're using too much water within that zone to cultivate certain crops. Low water levels and aquifer exhaustion, so those are just general terms, right? So we're just looking at lack of water availability. Solutions. So every solution essentially comes with its own potential problem. So we see build dams or reservoirs. So these are like artificial lakes where we're storing water. Of course, if you go back to the situation of the United States and Mexico and the Colorado River, if the U.S. is damming all the water from the Colorado River, okay, to create these reservoirs, then that's decreasing the flow further downstream and causing problems for other people. Desalination, this is a process by which we could take salt water and essentially convert it to fresh water to be drinkable. It consumes a huge amount of energy, and really for most locations is not worthwhile unless you live in an extremely wealthy country. Rainwater harvesting, so this would mean you can put like a bucket essentially under a downspout and collect water that way. And you can do this in a domestic situation as well. In fact, rainwater harvesting used to be illegal in Colorado because it was considered stealing, or not, I guess stealing is a little bit strong, but taking water that belonged to everyone. So taking this common resource and using it just for yourself, and it was illegal. But then in recent years they've changed that so that now you can actually harvest rainwater within your home to use maybe for watering or whatever you want. And it's no longer considered illegal, so that change has been made. Artificial recharge of aquifers, so this would be trying to add water to zones to refill the ground storage of water. There's stories of people doing this in California, so just kind of watering the ground to recharge an aquifer that was below a vineyard in that case, because it's California, so there's lots of vineyards. So someone was in a time of rain trying to get as much water as they possibly could and additionally water the ground on their huge vineyard so that they were recharging the aquifer, and when they needed it, they could pump that water out. So solutions. Here are some simple solutions. Again, they're not going to solve everything. So we're talking about more efficient domestic use. This is number one, what we talk about. But remember, only a small percentage of the water is used domestically. So even if you reduce the amount of water to flush a toilet or you turn off the water when you're brushing your teeth, it is going to help the situation, but it's not the solution that we really need. We really need like a big scale solution overall. Gray water cycling, so this is using water that's perhaps been used to wash dishes, etc., to do something else. So if I used water in my house in the sink to wash dishes, that somehow that water would then go into, let's say, the toilet, and then it would be used to flush the toilet. So I wouldn't be using brand new clean filtered water to flush my toilet. I'd be using this gray water, so this like semi-used water. Okay, rainwater harvesting we just talked about. Drought-resistant crops, so changing what we grow and where we grow it. Drip irrigation, so instead of spraying water over large fields that might evaporate, just watering closer to the ground. And water at night. So if you water, they say either throughout the night or really, really early in the morning, that reduces the amount of water evaporation. So you're getting like more bang for your buck, essentially, if you're watering at those points in time. Degradation issues. So degradation is reduction in quality. So now we're looking at contamination, salinization of the top of soils. We see a lot of salinization in the Aral Sea area as the water evaporates. What is left behind is really just like desert, essentially. Overuse of fertilizers and pesticides, so that goes along with the eutrophication, industrial pollutants, and the release of warm water, which can hugely impact a zone. So if we're watering with warm water, you can imagine that could be devastating to some of the organisms within that zone, as well as actually change the quality of the water in many ways as well, because they say, cold water actually holds oxygen better than warm water. So if you're changing the water temperature, it's going to create some issues. Okay, solutions. So these are a simple list of suggested solutions. Organic farming, be selective with the pesticides, so things that are less damaging, less likely to contaminate waters. It says industry removes pollutants before they could get into the water source. regulate the temperature of water so that we're not adding hot or warm water into a situation, and then of course pass laws, right, to monitor these situations and to prevent further contamination and degradation from occurring. Water wars, okay, we saw some issues with the water in many locations, including the Ganges, which I forgot to talk about in the first class, but just super interesting things happening in India with the Ganges River, as well as in all of these other zones. There's many issues as well, along with what we saw in class. So just really